I just want to quickly talk about the electric motor. So the driveline, so your electric motor, the reduction gearbox, you know, how that comes into efficiency as well. Now the electric motor in the Model 3, and I think now in the newer Model S's and Model X's, it's a permanent magnet motor, but it's a different type of permanent magnet motor. So it's an IPM synchronous motor, so it's a internal permanent magnet motor. So the permanent magnets are on the rotating part of the motor, the rotor. So the inside, the interior of the motor, you could call it, and that's, you know, what propels the motor forward. So it uses magnetic field. So there's a rotating magnetic field on the outside of the motor. So it rotates with the rotor, the rotating part of the motor. Now I'm going to do another video just on the motor because I think that really warrants a video on its own. So I won't go into too much detail, but the Model 3, when it was released, Tesla changed. They went away from the induction style motors. Now induction style motors, the rotating magnetic field on the outside has to induce a magnetic field onto the rotor. The rotor doesn't have permanent magnets, so it relies on the induction of that, the magnetic field rotating on the outside part of the motor to induce a current to flow on the coils on the inside of the motor, which then generates a magnetic field. Now, having to do that, there's a bit of slip in that process. That's a way to describe it. So that outer magnetic field has to rotate at a different speed to the rotor, the center part, to generate that EMF in the rotor. So that is a bit less efficient than a permanent magnet motor, and which just has that magnetic field there all the time permanently. It's built into the magnets. So that's a bit less efficient. The permanent magnet motors are much more efficient at low speed. They don't have that slip. You have that rotating magnetic field is synchronous with the rotation of the rotor, and that's why they call it a synchronous motor. So it's all to do with the rotating magnetic field on the outer part of the motor synchronizing with the rotor, the center part. But as a downside to permanent magnet motors is at high speed, they can be less efficient because those permanent magnets then work against things and they start trying to generate or induce a current to flow in the outer windings of the motor, and that can generate some heat, and that makes it less efficient, and you know that heat is wasted heat. So the motor in the Model 3 has a way of dealing with that, and it's all to do with the timing of that outer magnetic field rotating, and I'll go into that in a bit more detail. But basically in the Model 3, the motor is efficient at low and high speed because of that, and you know that's pretty cool. So I think that warrants a video on its own. I've actually got, I don't have a Model 3 motor to pull apart, but I do have a smaller brushless DC motor, which is a very similar setup, and it will allow me to explain and just show you the main components of the motor and what I'm talking about there. It'll help illustrate how an electric motor works. For those of you that don't know that, hopefully that can be an interesting video for some of you guys. We'll do that as a separate one. So the motor is super efficient. I just wanted to briefly touch on that. Then that motor interfaces or connects to a reduction gearbox. So there's a reduction gearbox there to give the motor a torque increase, and it's a 9-to-1 ratio. So the electric motor has to turn 9 times faster than the output of the gearbox, which is the shafts going out to your wheels. And that is to make it much more efficient at takeoff. And Tesla would have worked out the most efficient ratio to have there that gives you, requires less energy for the car to take off from standstill. Plus also make sure that the motor isn't spinning too fast at the maximum speed of the car. So I think at the maximum speed of this car, the electric motor is turning at like 18,000 RPM roughly. It's up somewhere around that. I've never taken this car to 200 and something kilometers an hour, Just not possible to do that legally on the roads here in Australia. Maybe if I lived in Germany on the Autobahn, you could take the car up to its max speed and see what RPM the motor does. But anyway, it's a really fast RPM at that speed. So you want to find a balance in between the max speed of the motor and then the efficiency at low speed for takeoff. And I think Tesla have found a pretty good balance there. The other thing when you're talking about mechanical gearboxes, and that's what I work with at the moment. I work with power shift transmissions, gearboxes to run hydraulic pumps off motors, both electric and diesel engines, and axles, drive systems, planetary drives, and we import, we sell and repair those. So I've seen in my time thousands of gearboxes that have failed, and I get to see what how they're designed. So with gearboxes, I can start with the gear teeth. So gear teeth, you've got different ways of having gearbox teeth mesh. So you have angled teeth. When the teeth mesh with each other, you can have teeth that meet at an angle. They're called helical gears. Or you can have straight cut gears where the gear teeth parallel to the axis of rotation. And helical gears, when they mesh, they end up creating an axial load, when they push against each other, they're meeting at an angle, so they're trying to push out axially in each direction. So that's going to push on the that's going to push on the back out onto the bearings. So you would then have to have tapered roller bearings, and they're going to generate a bit more heat. You're going to have some load there to some extra load there on those bearings because those gears are pushing off to the side. But you can also do that with ball bearings to a certain extent. And from what I can see, Tesla use some pretty heavy duty ball bearings in the gearboxes. But gear teeth, still, it's the design of those gear teeth, the class of finish on the teeth. There's going to be a common theme with this now, is to reduce friction. So those gear teeth, the design of those gear teeth, the finish of those gear teeth decides the friction that's generated when they mesh. So have nice smooth ground teeth, you're going to reduce that friction. And that's one thing we want to try and do with gearboxes, is reduce friction. Friction generates heat, it generates wear, and it's a waste. So keeping friction to a minimum is what is the key with gearbox design. And so we've seen that with gear teeth, you can minimize friction. Bearing choice, you can also minimize friction. So bearings have changed a lot over the years. Really, no matter where you buy your bearings from these days, well, not really, everywhere, but most bearings these days are made to pretty good quality. So you're getting pretty good consistency of manufacturing there, consistency of tolerances, and it's pretty rare these days to come across bad bearings. So yeah, I think bearing choice is the key there. Your traditional, ball bearings can be quite good. I've seen them now made out of many different materials. I've seen them come with special heat treats, special materials, and special heat treats of the races to prolong the life and to reduce friction. So that's the key. So that bearing choice. The other thing to consider is the fit of the bearing. So the fit of the bearing decides what clearances there are inside the bearing once it's up at operating temperature, and that's something to consider. So the rule of thumb with the bearings is one of the races, either the outer race or the inner race, needs to be a slip fit to allow the races to align themselves and to allow for expansion of the bearing once it heats up. So with a lot of the gearboxes I work with, the outer race is a slip fit in the housing, and that allows that outer race to creep around and distribute wear across the whole race. It allows the bearing, the ball, the inner and the outer race to align themselves, and that really maximizes that wear life of the bearing, and yeah, you get the most life you can out of that bearing. The next thing we work, one of the key critical things then, all these things work together. So the last but not least is oil. Oil is one of those things that people overlook. They try and save some money on oil. They think, the sales rep comes along and selling them this oil, it's this fantastic oil, but there's a lot of merit to that. Oil is super critical. I know with our products, it's a battle trying to get people to use either the right grade of oil, which is like the thickness of the oil, and how that circulates through the gearbox, how easily that circulates can decide cooling, getting lubrication to where it needs to go, flowing through splines and things within the gearbox. So it's super critical. Now, an oil that stands up to higher temperatures, its lubrication properties at higher temperatures can also be an issue. Now, really good oil, what it is doing, it's keeping the metal to metal contact to a minimum. So you want your oil to create a nice film between the metal surfaces, to reduce that friction and reduce that metal to metal contact as much as possible. And a good oil will do that, and will do that for a long time. So you reduce wear, you're reducing friction, you're reducing unnecessary heat, and you're prolonging the life of the gearbox. Now, in the manual for this car, it has service intervals for different things, and I can't see anywhere in that service interval maintenance part of the manual that says to change the gearbox oil. So you look through manuals for an ICE engine car, and there's motor oil changes, there's gearbox oil changes, there's axle oil changes, there's filter changes, there's so many things to service, so many wearing components. But what it looks like is that Tesla has made a sealed for life gearbox. Now, some higher end auto manufacturers like BMW and Mercedes and Volkswagen, they've created some sealed for life gearboxes, and I think they've worked out that over a certain amount of kilometers there's an acceptable amount of contamination in the gearbox through spline wear and gear tooth wear, and they know 100,000 kilometers, 200,000 kilometers, I think they've worked it down to a fine art of how much wear under normal conditions there's going to be, how much contamination there's going to be within the oil, and they've got enough data of years and years of data to know that they can get away with that oil not being changed in that gearbox through the life of the car even. So from what I can see, Tesla, of that reduction gearbox is sealed for life. So there's no maintenance that needs to be done there. Really, with this car, the only maintenance you're going to do is change the tyres every 40 or 50,000 kilometres. Every couple of years, you may need to change the cooling fluid in the battery, in the motor cooling system, and possibly the cabin air filters. So every couple of years. So really, there's not a lot of maintenance to be done, which is where you start saving a lot of money with an EV. So I'm pretty sure I've covered all the points that I wanted to today. Guys, if you got any questions, as always, throw some questions in the comments. It's another longish video. I've just got so much information to share with you guys, so many interesting things about this car and EVs in general. A lot of the things I've spoken to you about today aren't unique to Tesla. The aerodynamic, the tricks they use for aerodynamics to reduce drag aren't unique to Tesla. The heat pump isn't unique to Tesla. The electric motors aren't unique. I think Hyundai use a very similar electric motor, the synchronous permanent magnet motors. So it's not unique. So I think really from this video I've made today, even if you don't have a Tesla, there should be some interesting info there for you. So guys, I'm almost at work. Once again, ended up being a longer video, and I appreciate it if you've sat through it. A lot of technical things here. Guys, let me know any other videos, any questions you've got. As you know, with my videos, I like to respond to every comment. Any questions, I like to respond to them, come back to you and answer your questions to the best of my knowledge. So guys, thanks again. I'm pretty humbled by, you know, I really didn't expect as much views as I'm getting. I really just wanted to put these videos out there, and I thought if I can help 1, 2, 3, 4, 5 people, I'd be grateful. So yeah, look, I'm